Number 11. Okay, so we have x squared y double prime plus 5xy prime plus 4y equals 0. And again, we're verifying that y1 and y2 are solutions to this differential equation. So the first one is 1 over x squared, and ln of x over x squared, right, where ln is really the log of x with base e. Okay, so let's start with y1. Now remember, we're going to be taking derivatives, so we really don't want this as a fraction, right? Let's use negative exponents. So we can rewrite this as x to the negative 2, right? Again, I'm using x to the negative n is 1 over x to the n, right? I can rewrite those expressions, and well, might as well, let's just do this one. This is ln of x, and it's times x to the negative 2, right? There's a product here. And I wrote parentheses around ln of x. So let me, just because it's a common error I see all the time. Sometimes students write, okay, so don't do. Some students want to write ln of x, times x to the negative 2, and then they say, oh, I can do ln of, that's a power of 1, the same base, I can add these, so I get x to the negative 1, and so forth. Okay, this is wrong because ln of x is ln doesn't make sense without an input, right? This is a function, ln of x, so the ln has to go with some variable. So to avoid any mistakes, I encourage you to put parentheses around this. So I don't want you to get confused. Okay, don't do that. All right, let's continue with the problem. Oops. Okay, so where is my pointer? Okay, so let's substitute 1 over x squared, which is x to the negative 2. So x squared times x to the negative 2, right? And I'm taking two derivatives, plus 5x, again, x to negative 2, one derivative. So that is a negative 2, and that is prime, plus 4y. So does that give me 0? And let's see. Well, x is just x squared. And it doesn't look right. And my eraser again, not sure why it's not erasing. Okay, let's go back here. So we have x squared times the derivative, the second derivative, so we can rewrite this again as x to the negative 2, right? I'm going to take the first derivative of that, and then I'm going to take the second derivative. Okay, I encourage you to write this expression like this, just because I've seen so many students that go from here to here, and they're always making a mistake, and it's usually just because they don't want to write that intermediate step. So again, the intermediate step is going, it can only help you. Okay, so we have plus 5x, and the derivative of x to the negative 2 is negative 2x to the negative 3, that's a 3 up there, plus 4y. Okay, so we have x squared, and the derivative of this guy, right, is negative 2x to the negative 3. And again, I still have to take the second derivative. And I already took derivatives here, so we can just multiply these guys. And we have negative 10x to the, it's a power of 1, so negative 2. And I just realized I never plugged in the last y, which is our x to the negative 2. So x squared, and the derivative, again, of this function inside, right? So it's the power rule with a constant outside. So we have negative 2 times negative 3, x to the negative 4, and I can just rewrite everything else, and these are actually going to combine, right? Okay, so we have, we know these guys are going to be, so negative 10 plus 4 is 6x to the negative 2, and we have x squared, and we have 6 here times x to the negative 4, and we have the same base, so we can add these exponents. So we have negative 2, and then we can see that these are going to give me 0. Therefore, y1 is a solution to the differential equation above. Okay, so the next part for your homework, actually, I still want you to do number 11, but I want you to check the next one. I want you to verify that y2 is a solution to this differential equation. So there you're going to be using the product rule. So make sure to look at that. And that's it for number 11.